What's the relationship between a programmer and AI? Does the AI machine write the program? Well, if you're a dumb or a lazy programmer, the answer would be AI writes the program. And what it produces, you don't have a clue what's going on. So you can't defend it. A much better approach is to use AI as a tool or a collaborator to write that program. And to demonstrate that, I'm going to go through some steps on this quantum research project or quantum molecular research project and show how I do the different steps. I will talk about my ideas and then I will pose a question to AI and then we'll come up with those results and then we'll decide whether those are good results. If they're bad results, then we'll question further until we get what we think we can defend. We have to be able to defend the program that we write. Let's start at a super high level. Here's main. We'll look at main in just a little bit. But main has the selections in it. It selects what kind of experiments we want to run, geometry optimization, basis scaling. In this folder, we have the molecules that we want to look at. We'll just look at one molecule at a time, all the way from hydrogen up to some of the nitrogenase pieces, because that's my focus is nitrogenase. And then some results can go in here, and some plots can go in there. And what's in core? Well, core are the guts of what's going to happen. Inside core is the quantum chemistry type code. And this is going to be the most mysterious part. We can handle all this ourselves, but figuring out what's in this core is going to be, well, that's going to be the tough part. Now, let's look at main. Okay, here's main. And main is not complete yet, but here's the method main, and here we're actually calling it down here. But anyway, notice these are just a bunch of print statements. But the important part is that I come up with the experiments first. You select an experiment, then you select a molecule. Here you select a molecule, and between experiment choice and molecule choice, it will choose the rest of what's going on from the folders that we haven't quite presented yet. Before we start writing software or flowcharts or anything else, we should start with requirements. So I thought, why not let AI and I communicate together, collaborate together to come up with some good requirements. So let's look what I started out with. Let's work on requirements for main PI for quantum chemistry research folder. As we saw before, main is outside all the other folders, and the folders have all the supporting files that make everything work. So what I said is, let's have the opening screen allow selection of a molecule followed by selection of experiment. Now you notice I switched things around from that last screen, but I think it makes more sense. You want to focus on a molecule, and then you want to look at the different properties of the different experiments that come out of that particular molecule. Everything in nitrogenase is focused on a molecule, so I think it makes more sense to start there. Then I said selection of unsupported molecule on list will have no action other than requesting input again in like manner an invalid input value. Now again, notice how general these things are that I come up with, because I want AI will pick the heck out of it and it will come up with different viewpoints on this stuff, especially because AI does a lot of programming. Now, let's say selection of experiment unsupported and invalid input value will act the same as the selection of molecule, or it would just add that input again. Notice my write-up is not that great. Now let's see what AI comes up with. This is what AI would do. I would separate molecule selection from experiment selection and make the menu behavior deterministic and fault tolerant. Is that changing anything that I want? Not really. But what it will do is it will generate requirements, and then I can decide, are those the requirements I want or not? Upon launch, you have the application banner, display list of supported molecules. So I guess those could be two different things. We could have some opening thing and some delay, and then a display list of supported molecules. Then prompt user for molecule selection, validate selection. Like some of the molecules on this selection screen, I might not have ready yet. So I have to have some way of handling that. If valid, proceed to experiment menu. If invalid or unsupported, redisplay molecule menu. Now that's not much different than what I just said. So that seems to match everything. Molecule selection requirements. Here's a bunch of molecules, and 0 is exit. So that'll just exit the whole program. And we'll see that we can come back to this screen when we want to exit it. Now, let's see. If molecule is implemented, as I said, some of these molecules aren't going to be ready to go. So let's see. Selected NH3. I know I have that one. That's the NH3 molecule, the basis scaling. That's going to be the one that we go through the most here. Okay, now we go to experiment menu. If molecule, it appears in menu, but implementation is not complete. Let's see, we put out a sentence here. Not yet implemented, please select another molecule for that experiment. See, it may depend on which experiment I choose as to which molecule I want to do. Return to molecule menu. No exception, no program termination. So you just go right back to molecule menu. That's your home base, if you want to think about it that way. And invalid input. These are just goofy things that don't relate to what's on the menu. Invalid selection. Please try again. Return to molecule menu. So at least we give the error thing. That's something that I didn't produce in mine, and it's probably a good idea to put that in there. Now let's see what we got here. After a valid molecule selection, basis, and this is the one that I have prepared already for NH3, and I'm going to be incorporating that into this new structure. All these others aren't done yet. You can always go back to the molecule menu, and from there you can exit. So that's something I didn't think about. And this is kind of it seems like a good idea. Okay, if experiment exists and is implemented, then you select something, you select running NH3 basis set scaling. Oh, I see. This says put the message up there and then call the corresponding experiment function. So this is going to require a little bit more code than I thought, but it's good to have this framework set up right for main before you go on to all this other stuff. If experiment is listed but not yet implemented, resource estimation is not yet implemented. So I have to have print statements for all these different things. then return to molecule selection and molecule menu. Invalid experiment input. Okay, invalid experiment selection, returning to molecule selection. So we always go back to home base when we have some goofy thing that we put in there. Okay, this follows your stated requirement and returns to the molecule selection state. Here's a state machine view of all this, which would be really helpful when you're writing the code. So did AI do everything for me? AI hasn't written one single entry of code yet. So all it's done is just helping me think through this. And if I want to change this state machine, I will. Maybe I don't want to always come back to the molecule menu, but I can if I want to. And then it shows some architecture. Man, this is interesting. Menu.py. So maybe main.py calls menu.py. That has the actual functionality of this. Might have to ask a question along those lines. I will say something like, I notice you suggest that menu.py be in core. And I'm going to say, this is curious to me. Please explain. Let's see what it comes back to. And it comes back, that's a good architectural question. The reason I suggest it is that I view the menu system as framework infrastructure, not chemistry, and not an experiment. Let's look at the responsibilities. Nothing here should know about menus. I agree with that. Okay, now let's see. I thought core was the chemistry. Not sure whether to close this video off yet or just call it requirements, or maybe I will go ahead and publish this because I've got to do some thinking before I can go on here. So, wow, there's a whole bunch of stuff here about just that one question I had. This is exactly the behavior that makes large multi-file projects like yours framework manageable. Maybe a little boring video, but I hope you get the idea of requirements in AI and how to use AI without being lazy or dumb.